And good morning all. So today we're doing chapter 9, which is the first of our virtualization chapters. And this one gives you a very brief look at what virtualization is and cloud computing. And the lab for this chapter is to install a Linux operating system in a virtual machine. Chapter 10 is the Windows installation on a virtual machine and setting up a few user accounts and stuff like that on it. So we might cover both today, but I didn't pre-read chapter 10, so we'll see how we go. So we'll look at what virtualization servers are, types of software that you can use to do it, what cloud computing is and how you can do it. And for just before the recording started, I was talking about you should be able to get some of the files from my Dropbox, like the Linux file, I think it's in there, and the VM player link is to VMware itself. And I think under the new license you get like 90 days free trial or something like that with it, so that's more than enough for doing what we need to do here during this course. The those links are available via the PDF, which is on our Discord server under ICT NWK 420. So, all right. What is virtualization? Well, virtualization is where you use the hardware of one machine and run many or a few, depending on your application, different operating systems or virtual machines on the same set of hardware. So with a virtual machine, it is an image, it's a software application, so it can be stopped and started as needed. And it's not like dedicated hardware. So what you're doing is you are saving on physical hardware costs. So you've got a cost saving to the business and energy savings, which equates to making ICT a little greener, more sustainable, because we're using less energy to run the same services. And virtualization is what kicked off in a big way the cloud computing genre that is now everywhere. So service providers such as Amazon Web Services own and manage their own cloud infrastructure, and with AWS it's very cheap and easy relatively to upscale and downscale your services as required compared to traditional hardware requirements. So traditionally we used to run different servers for each type of service we were offering. So we'd have an email server, SQL server, file servers, web servers, and we would buy the same hardware, the same memory, and basically all what would be different on these servers would be the application running on the operating system. So they'd all basically be running a Windows server, but running a different element of service within that infrastructure. So with virtualization, we call the software that handles all the virtual machine, a hypervisor, which is the link between the operating systems and the hardware. So this, if you like, duplicates the individual kernels. Remember, we talked about the three elements of an operating system being the GUI, the kernel, and then the hardware. So within each of these individual virtual machines, the operating system still has that kernel in it, but instead of talking directly to the hardware, it now talks to the hypervisor, which is what it sees as its hardware. Okay, so each operating system can talk to the hypervisor, and the hypervisor does the juggling act to give them access to the hardware as they need it. Each virtual machine is a standalone server, and it doesn't share operating resources with its neighbors as far as the software is concerned. So, as I said, less energy, less cost. You can roll out new servers very quickly. Generally speaking, you have better uptime. Disaster recovery is quicker because you basically only need to bring up one or fewer hardware servers, and then you're just kicking off the applications. So it's much easier to get them to recover, and they are able to support all the older traditional legacy servers and systems. So as far as a network is concerned, from a host perspective, there is no difference from accessing a virtual server compared to a traditional server. You won't even see the difference. You may actually see an improvement in performance. So client-side virtualization allows us to do the same thing on a host computer, which is what we'll be doing. And we can run host operating systems on top of our host machine. So we have the physical hardware down here. We've got the host operating system. Then we have our equivalent to our hypervisor running here, which is VirtualBox or VMware, whichever one we choose to go with. And then we can run the various virtual machines, which they're referring to as a guest operating system there. Now, generally speaking, there's different methods of doing it, but general rule of thumb is you tend to run like on like, but you don't actually have to. You can run a Apple operating system on a Windows machine and vice versa. It just makes life so much easier for experimenting and checking compatibility between systems. So our types of hypervisors is type 1 is our native, which is used for server virtualization in data centers and cloud computing, and run directly on the hardware of the host. Okay, whereas our type 2 basically run on the host machine. So I don't have to sort of say that because we just went through that on the other slides. So type 1 hypervisor runs directly on hardware. type 2 basically run within an operating system on a host machine. So what do you need? Well, you need a host operating system. You need a processor, preferably with 64-bit, second level address translation. It's got to support virtualization in the BIOS. Memory, minimum 4 gig, but it's recommended that, like any machine, the more RAM you have, the better the performance. And hard drive space, minimum 15 gig per virtual machine. Hyper-V is a Microsoft version of virtual machines, and I don't recommend it. The Microsoft purists will be jumping up and down. The reason I don't recommend it is Hyper-V can actually change the host DLLs, so the dynamic libraries, on the actual host operating system, whereas the ones with the VMware and VBox and that tend to be self-contained and don't make changes to the base host operating system. So they're much more robust. You then have your host OS, and again the hard drive space and so forth for Windows 8, Windows 7. Alright, so basically common theme there, 15 gig for a virtual operating system, and memory, standard recommended memory for minimum okay, so I left the lab slide in for a change. So we're going to prepare a computer for virtualization. We're going to install Linux, and hopefully you'll download the Kali Linux, because later on, if we want to look at hardening an operating system, Kali has some inbuilt security features that become useful when we're looking at cybersecurity and an operating system. Excuse me. So the next part of that is exploring the GUI on the Linux. Now, it's been a long time since I've played with Linux, and I've not installed Kali version of the Linux before, so it'll be a learning exercise for me as well. Okay, second half of today is cloud services, cloud computing. So we've got three main elements. We have software as a service, SaaS, platform as a service, PaaS, and then infrastructure as a service, which is ICE. Or ICE. Got to be careful with that one, don't we? Alright, so the bottom one can also be extended to be all of IT as a service, basically, which some departments, some businesses might outsource all of their basic requirements to a infrastructure service provider. Okay, so typically you would find SaaS, which would be, your email service, your Office 365, that type of infrastructure being provided to you on a subscription basis, which is a very common model now. And then you've got the platform, where your tools and services are included in your subscription. Okay, so not much difference. So it's just expanding functionality between the two as you go down. So the benefits of cloud computing is it is basically an on-demand service. So it's very quickly upgraded and expanded on. So it's got what they call rapid elasticity. In other words, you can grow and shrink it as you need. All your resources are pooled. Everything is metered and measured, so you can have fine granular analysis of how your network access the various elements of services, and it gives you broad network access. Now, one of the things that the marketing people never talk about is you're super reliant on your service providers now. Everything before used to be contained within your business. Now you need larger pipes to the outside world, because all that network traffic that used to be running at, fast local speed on your LAN now needs to be pushed out onto the internet and across to your service provider. And where is your service provider? What privacy laws do they follow? Do they instantaneously move your data around the world like Amazon does? All right. Their data centers are set up in such a way that everything's mirrored and can fail over to backup systems instantaneously. So you cannot be sure where your data is actually located and what laws protect that data. So just be aware of that one when people start talking about how fantastic cloud services are to you. So in conclusion, virtualization is good. It saves resources, energy. So in business perspective, it's a cost-saving manager to help save the planet. It uses less resources, therefore it's more sustainable. Basically, a cloud service, anything when they refer to cloud computing, is any service that is offered remotely. Okay, I've given you a cloud service as the second slide. What? Huh? Dropbox. It's a cloud service. Okay, it's a service. SaaS, software as a service. All right. So there's a. So that was one of the quickest chapters you'll see me go through in this. All right. So. No, I'm not going to uninstall my licensed version of 12 to get an unlicensed version of 15. Sorry. So I'm sure you have worked out how to install applications by this day and age. All right. So as you can see, I've played around with some virtual machines, GNS. I've got a study PC that I play around with. It's an old Windows XP. That's all right, Stuart. This is recorded so you can come back and step through it. Installing virtual machines is pretty much point and click. It's very easy to do, and so basically the way it is you come in and create a new virtual machine. Now I'm running off memory, and so it's been a while since I've done this, because once you create them, your base one, you can just copy them and have as many as you need. Alright, so I'm going to drag this over into here. So I've got in my Dropbox folder the iOSs, which should also have been in under here somewhere. There they are. So if you've got the original DVD, install off the DVD, it's fine. If you've got the ISO, you can browse to it, and in this case it's under my teaching resources for the cluster, and boom, there's the ISO image. I'm not sure what this image is, need to specify it, or you can just click the last one, which will set up the shell of the machine and then install the operating system onto it. So basically, if you take the last option, it creates the virtual hardware, and then you have to do a operating system install as if you are booting up hardware for the first time without an operating system. So in this case, I'm going to go Linux, and oh, I can't remember. I think it's on the Red Hat. I can't remember which version of Red Hat it is. So I'll just, there you go. And then where am I going to create this virtual machine? Well, I'm going to create it under my teaching file structures, and I'm going to make a new one called VMs. So I'm going to make this new virtual machine in this location, and recommended hard disk size. Now, I would always recommend splitting your virtual disk into multiple files. This allows you to copy your virtual machines much, much easier. If you have to, especially in the older days when our thumb drives weren't as large, we could actually span it across multiple thumb drives and stuff like that if we needed to. It just makes copying and moving these virtual machines easier to have it split in multiple drives, and it can then add and subtract and adjust that disk size much easier as well. Remember, it's virtual. You can add hard drive space by just adjusting the figure. Okay, so there we're going to go through with our various memory allocations, finish. There's the virtual machine, and you should hit play. And there it's going. Software update, remind me later. Alright, so graphic install, advanced options, graphic install, return to your host with Control-Alt, drag this down. Yes, you don't like it because it's not in your little listing of fantastic little web pages. Yes, I know, I get the message. Knock her off. My antivirus is having an issue with Kelly because Kelly has security features in it that trigger antivirus software. Decent ones anyway. Alright, so International Cybersecurity Institute over in the UK, icsi.co.uk, is offering a free course. Okay, so Certified Network Security Specialist, normally charge you £500. If you register by the 30th of the 6th with the voucher code #StaySafeHome, you will gain access to their course. Now, their course offering, the free offering, doesn't give you access to their labs and stuff like that. It's just the curriculum. But it enables you to do a bit of reading around device hardening and so on. 94 lessons that are broken down, and this has failed. That's not good. Oh, it's on Debian, and I chose Red Hat. That could be the problem. I thought it was on a Red Hat. Alright, let's abort that. Because it won't like that at all. But, alright. So, this course is quite an interesting read. And I've got a bucketload of... For a full Kelly installation video that works, and jump across to the Kelly installation video, which will be linked here. Bye for now.